and respected delegates. Welcome to Day 2 of India Space Congress 2024. Well, I'm Dr. Azra Khan, and I'm extremely delighted to be your host for this beautiful day ahead. Well, can we start this beautiful morning with a huge, huge round of applause and put some energy into this room? Wow, thank you. Thank you so much. Well, today we have several discussions about mega-constellations, where our first session for today is satellite constellations, mega-constellations, opportunities and challenges. The race for mega-satellite constellations bring opportunities and risk. While promising better internet and reduced latency, concerns about aviation safety, astronomy, and private influence arise. With nearly 1 million satellites awaiting launch approval, governance is vital. Session talks about rising demand and balancing pros and cons. Now, I want you all to please help me welcome our chairperson for today, Mr. Jeremy Rose, partner at Comsys LLP Panellists. Also, I would like to welcome all our panelists, Mr. Damodaran Raman, Director at Deloitte Consulting, Mr. Ajmair Heer, General Manager at Astranis Space Technologies, Mr. Alexander Jeuck, Senior Advisor, Novaspace, and Mr. Sethu Saveda Suvanam, Founder and CEO at ReOrbit. Can we welcome all our panelists with a huge, huge round of applause? Come on, ladies and gentlemen. Well, I request our chairperson to please lead the discussion for today. Thank you so much.
Thank you very much indeed, and welcome to you all. It's always good to get the clapping before, because then it's basically just get that over with. We've had our panel introduced, and let me just introduce myself just quickly. My name is Jeremy Rose. I'm a partner at Comsys in London. We do satellite communications, technical due diligence, commercial market due diligence, and you can find more on our website. Thank you very much indeed, gentlemen. We heard what the panel description is going to be, so let's just try and sort of keep it to what it says on the tin. So mega-constellations, I think maybe it's a misnomer, because of the 1 million satellites that we've talked about, at least 300,000 probably won't happen. But we're certainly talking about tens of thousands of satellites. And what's really interesting over the last 2 years, we've been in the consulting industry here in the satellite communications sector for about 40 years or so, is a complete and utter disruption of what we thought was the case in terms of the satellite communications market. Just a change, if you will, or maybe a migration from geostationary satellite to non-geostationary, a complete upending of the perceived wisdom about the way in which business is done. Some of you may know that I do the program for the Satellite Industry Forum in Singapore in June. Historically, Arianespace was always the launch sponsor. And about 10, 12 years ago, I said, we ought to have these guys, SpaceX, speaking as well. And they said, no, absolutely not. These are upstarts. They're not even members of the CASBAR, the Cable Satellite Broadcasting Association of Asia, who organised the event. Of course, now, SpaceX are the guys who are saying that the Arianespace guys shouldn't be talking. What's interesting is that SpaceX, Starlink, Elon Musk has changed everything. Landing launchers in Cape Canaveral. I don't know if any of you have been to the SpaceX factory where they build the rockets just south of Los Angeles Airport. It's a humongous building. And in one end of the building, there's lots and lots of deliveries of metal powder. And at the other end of the building, within the building, there are lots of 3D printers. So you get metal powder at one end, you get rockets out the other end. And in the middle of the factory floor, there is the factory canteen where everybody has lunch. And you can sit down and get a burger and salad and soup and chips and whatever, and they're making rockets. And you think, what about clean room? And they say, well, no, we don't want to have a clean room. We're landing rockets on the beach. We don't want a clean room. There's a couple of tomatoes, there's a cucumber. It doesn't really matter too much.
And it's just that idea of concept of completely changing things, which has really changed everything. And everybody in the world has heard of Elon Musk. Nobody in the world has ever heard. Nobody goes home and says, honey, guess what? Kids, I got a phone call today from Utelsat. And like, who? No. I got a phone call today from Elon Musk. The kids are all saying, great, we're all going to be driving Teslas. So, and that's a very, very significant issue. The other issue is, there's issues of a key man. If Elon Musk gets kidnapped by Martians tomorrow, what happens? He probably prays every man that he will. Who takes over? William Shotwell is an excellent person that nobody has heard about. So it really is a key man issue. The second issue, maybe the first, is with all of these mega-constellations, is our view is that the rocket science is the easy bit. It's the go-to-market strategy, which is the difficult bit. Alex is going to be giving us a little overview in a second, but I just want to give you my overview because I'm a moderator and I can do what I like. So basically, we all know what we're talking about. So we're talking about Starlink, OneWeb, Lightspeed, Kuiper as being sort of like the main four, and then there's quite a few others, Rivada, Mangata. He's based in the one that was a few hundred thousand filings. Let's just assume that's just not going to happen, or it's going to happen in some other way. Lots of Chinese filings as well. But there's issues, for example, of the panel description about low latency. Low latency, yeah, but actually how many people really need low latency? Well, really, there are lots of them who need low latency, but not everybody needs it. Can these services, some of them, Starlink, can they provide SLAs, service level agreements, committed information base? No, perhaps they could do in some cases, but again, not everybody needs an SLA. Then we've got the mobility issue and go-to-market strategy, how the sales are achieved with distribution partners. Iridium, 25, 30 years ago, failed because their DPs, their distribution partners, there were 16 of them around the world, and each one of them thought about three things: me, and me. Not about Iridium. So the way in which sales are conducted around the world is different, and the way in which the customers are managed is different as well. We did a go-to-market strategy for a satellite operator in Africa for a satellite broadband service a few years ago, and just the bullet points that we needed to deal with was 25 pages. Everything from the language in which the customer relations people talk, to the colour of the brochures, to the way that the money gets out of the country, the way that spares get into the country. But all of that is a little bit, upended again because of Starlink. And I was talking to a guy at a conference last year in Sydney. He's from New Zealand. They have KA band, Pacific terminals, and they have Starlink terminals. And he said, we had a cyclone here a few months ago. We had to send somebody out to each one of the KA band terminals, the Pacific terminals, and repoint them. With the Starlink terminal, he just basically emailed this guy saying, yeah, just stick it in the garden, put it on the roof, press the button, and 5 minutes later it says, yep, I've got it, I'm working. Significant difference in the way in which everything is conducted. I've waffled on a lot longer now. Alex, I'm going to give the floor to you for a few minutes. Is there anything I've missed about here? One other thing about Starlink. If you've heard of Quilty Space, Quilty, they're a organization in Florida. We've worked with them on some due diligence issues before, and they did a webinar a couple of weeks ago about SpaceX and Starlink. They basically estimate that Starlink's revenues are about $6.6 billion for this year, and they've been going for 3 years with 2.5 million subscribers. That's about 5 times as many subscribers as all of the other satellite broadband operators in the world, and it's greater than the revenues of Intelsat and SES combined. So it's a big mover. So I really have waffled on now. Alex, the floor is yours for a few minutes.
Thank you, Jeremy. Good morning, ladies and gentlemen. I would like to give you an overview of the presentation. Yes. So my name is Alexander Jeuck. I worked over the last 30 years for several companies in the space domain, the satcom domain, from Airbus, SES, as the engineering, and so on. And I'm presenting to you my role as a senior advisor to Novaspace. Novaspace is a new name, but it's the merger of Euroconsult Group and Space Tech Partners, the European powerhouse consultancy. And let's go. Okay, so when I heard about the topic of our panel, I was thinking, okay, mega-constellations. And I didn't want it to be too easy. I thought only about Starlink and ReOrbit. So we thought, okay, what is a mega-constellation? What we believe could be a mega-constellation. And there we have four domains.
So serving with the satellites.
Satellite communication. And these are the areas where we see mega-constellations.
At least long term also.
Navigation and space exploration. We don't think there are really mega-constellations.
Sorry, I'm just going to interrupt you there for a second.
So basically, there's going back to the second. Out, and I'll come up with my question later. What I was going to say that you talked about space situational awareness and PNT. Then they're very relevant, surely. I mean, it's SSA, space situational awareness in terms of debris, and PNT in terms of the way in which these satellites might be repurposed. For example, with OneWeb Gen 1 and Gen 2. So
No, we didn't say that it is not relevant. It is, but I don't see that there are hundreds of satellites built for that purpose. So this is the application.
okay.
So we need the batteries changed, or I don't know.
No signal, is that because of rain fade, or
Yeah.
talk about propagation issues?
Okay, we can move back. You can also manage it, yeah, from there, if that's easier for you. If we get the full screen and the first slide again.
I think you
Please.
need to enable editing, actually. So whilst we're waiting there, should we just get 30 seconds from each of the panelists about what you do at, Damu, so just who you are and what you do at Deloitte in relation, 30 seconds, and then, okay, we'll let's just, let's go for that, okay, whilst they're faffing around with that bit. Damu?
Yeah.
Okay. Oh.
So good morning, everybody. My name is Damodaran Raman. I started my career as a space scientist in ISRO. Sorry, am I audible now? Yeah, I started my career as a space scientist in ISRO for 15 years. Proud to say that the first batch of cryogenic development and then satellite whatnot. Subsequently, then I moved to IBM, close to 13-14 years as a digital transformation leader. And then I was a CTO and then many things. Currently, I'm working as a director in Deloitte, taking care of space, vertical, and then education. So that's about my introduction. I think we'll pass on to them. We have a lot more to discuss, subsequently.
Thank you. Good morning, everyone. My name is Aj. It's nice to be in India. It's the one place I can say my name correctly, Ajmair. Actually, everywhere else, everyone struggles with it. It's kind of funny that we're here talking about literally rocket science, but still we have the technology tax at the beginning of getting the slides working. There's a certain irony to that. I'm from Astranis Space Technologies. We're based in San Francisco. And very simply, we build and operate small geo satellites. We're only about 7 or 8 years old, but in that time, we've got well over $1 billion in committed orders for over 15 satellites, of which while they've not all been announced, 5 are committed to Asia Pacific. We announced 2 that'll go to the Philippines, and then, like I said, we've also announced 1 with Tycom, which we're incredibly proud of. We have our second launch coming up later on this year, which will launch 4 satellites, and then we already have a committed launch for next year, which will be an additional 5. So by the end of next year, we'll have 10 commercially operational geostationary satellites. I'll pause there for now and hand it on.
I'm Sethu, I'm the CEO and founder of ReOrbit. We build satellites, but we have a quite different view of how the satellites actually currently are operating and how the market would go. I think I take this slide. This is quite an interesting slide where you took the Earth observation and the SATCOM. So today, I mean, if you're looking at the space industry is segmented by application. Whereas if you look at similar industries on Earth, like mobiles, cell phone, computers, they're not actually segmented by applications, they're actually segmented by the data rates, right? Like when you buy a mobile, you don't buy a mobile for just taking picture or talking. You just buy a mobile which enables high data processing. And that's how we see the satellites would evolve, and we are building satellites in a similar approach where we build satellites as carrier of data, basically a flying router. And based on that, we have 2 different sort of segments where we have the geo telecoms, we have the LEO Earth observation satellites, and these are all connected so that at the end of the day, we are sort of pushing data up from LEOs to GEOs and GEOs back so that we could enable the fastest data rates flowing into the spacecraft and outside the spacecraft. And I can sort of unpack that as well.
Okay, we can go back to that. So, Alex, looks like we're back on track.
Okay, we are ready? So I say, when you please flip, yeah? So we keep the control with you. So, okay. So again, here, what we wanted to say here is where we will find mega-constellations, yeah? And this is, what is a mega-constellation? Is a mega-constellation something with 1,000, with 10,000, with 100,000 satellites? Or is it starting already with a larger constellation? And where will we find these larger constellations? And we believe that the larger constellations we see in the domains of Earth observation and satellite communication, less relevant. That doesn't mean from the topic and the subject is in principle the application of navigation and space situational awareness. We don't see that there are hundreds of satellites in one single constellation are utilized for this topic. Okay? So next slide, please. What is driving, we believe, the utilization of constellations, larger constellations, is in principle on Earth observation, is the diversification of payloads. And there you see the trend from 2012, where we have seen a few companies building these payloads. And if there are only a few kind of payloads, traditionally these were bigger payloads. Some of these payloads for Earth observation had been even added as hosted payloads, but depending on the LEOs. Don't flip, okay? So we having then already then in 2022, of course, the influence of new space companies. You can see on the companies' names here mentioned, Spire, ISA. These are companies coming in with their constellations, and we see many, many more coming in, because now we're seeing more and more also in which applications they are going, from hyperspectral, multispectral, SAR. These are the main drivers. Next slide, please. However, the main application for mega-constellation is today SATCOM. However, that is being driven at the end of the day by the market growth we see in the demand for satellite communication. And in our projection here, you see that for universal broadband access, there is a huge further demand coming up. Of course, that can be supported very well by constellations. And at the same time, also due to the geopolitical situation we have right now, we see there's a large driver for government and MIL-SATCOM needs in that domain, driven also by the low latency we have to say. Yeah? On the broadband access, it's spectrum usage, it's multiple usage of the spectrum in smaller beams, but we have gentlemen here on the board, they can say more about that. And yeah, next slide, please.
Sorry, can I just...
Yes, of course.
Yeah, go back. Well, oh, it's pretty dangerous to ask it. So basically, you've got a deep valley and then a big climb. But actually, those numbers are not that different. You've got 119 going down to 107, but then you're going up to 120, 123. So over, if we look at, say, before 2017 and after 2032, that is a very small look at what's going on. What's the general trend, say, from 10 years behind? I mean, is it a general trend up, or can you talk about that at all? I mean, the numbers are pretty much very similar.
What we also will see is that with mega constellations, with more and more satellites coming in, we need to build them cheaper and cheaper and cheaper. And I think that is one of the reflections we are seeing here, that if you want to build 10,000s of satellites, of course, they cannot come for the same amount of money than for smaller constellations. So the larger the constellations are getting, the price pressure is getting higher. And I only want to, for example, on the Telesat, you have seen they had a contract, they took away the contract, they renegotiated the contract, and I think it was nearly half the price. So,
right. I mean, anyhow. But these are revenues. I don't want to go into it in great detail. But you know, you're going down from 119 to 107 and 122. But then your universal broadband access in 2032 is going up from 15 to 38, which is a much greater increase. But anyway, we can go into those numbers later. Perhaps. Okay.
Next slide, please. So again, here on the panel, we're having people doing also GEO. So it's important to understand what we are talking there, because in principle also on GEO, if you are operating multiple GEO satellites, you can call this a constellation. This is absolutely right in my eyes, yeah. And there we're having, of course, the bigger players, the bigger satellite operators, and maybe Astranis will also come up there. And also, of course, here. We have then the MEO constellation. This is the SES mPOWER, which is in place, utilizing Ka band especially. But then the LEO. And on the LEO, traditionally, this is where we also have the demand then for much more satellites, because we are flying much lower. That means we are closer to Earth. That means also there needs to be more satellites to really cover then the whole Earth. Yeah? And there are different concepts depending on the orbits they are flying, depending on the concepts. And the two mega constellations having more than 1,000 satellites, this will be, of course, Amazon, Kuiper, which is now coming, yeah, and of course the Starlink, which having already quite a number of satellites up there. And also, of course, there's OneWeb with a little bit of different concept, but also with a large number of satellites which are in orbit. Next slide, please. Yeah, again, here you see the differentiation a little bit of the planned constellation size and how this is structured. In principle, the difference is also here on the altitude, but also in regards of the payload flexibility and the capacity. Yeah, you see that more and more spectrum is utilized also in higher frequency bands. There is a lot of discussion on utilizing QV band on feeder links now, so that they can free up Ka band links. But we are also seeing already E-band constellations in the discussion, because the higher we go, there's unutilized spectrum. Okay?
E-band is which?
E-band is 70 to 80 gigahertz.
Right.
Yeah.
Okay.
So it's QV band. There's above 40 gigahertz, depending how we then structure it. Yeah. But this is today used mainly on feeder links to free up capacity they can use on the downlink. Okay, next slide, please. Okay, here, filings. That is one important thing also to recognize. You cannot launch a constellation until you have done the filings, yeah? And the filings, in principle, giving us an idea of what is coming. However, it also requires to happen, because if you are not launching the satellites fast enough, ITU is restricting you to having all that numbers. But again, here are the big players, Starlink, Eutelsat with OneWeb. But then we also having a fleet, for example, which is using filings from the Solomon Islands. It doesn't need to be always the filings of the countries where the headquarters of the companies. We're having company Omnispace who wanted to use the filing of Papua New Guinea. Same time, we have to mention that in China, there's a number of constellations proposed. Yeah, about 65 we are saying here. And one of the very biggest filings, you mentioned already the country, was done in Rwanda. And we will see, yeah, how this will happen. Because if you are having so many satellites in orbit, you need to manage it and control it. Next slide, please. Okay, short overview about the offices of Novaspace. So it's a global company providing consultancy in the space domain. Next slide. And
more information on your website.
Exactly.
Yeah, okay.
Thank you.
Alex, thank you very much for that. So I'm going to turn over to Damu now. And Deloitte, I mean, you mentioned you've been doing a lot of work in defining the addressable market sectors. So, and you sent some very, very useful notes. And just wondering whether you could just talk through those for say 5 minutes or so. Yeah. Thank you.
Hope this works. So I could see that the audience, when we talk about KU band, X band, this band, right, everybody is looking into. So looking at the audience, I think I could see the youngest kid sitting in front of us. So I thought that being a consultant, let me clear the fundamentals, right, the basic things to what this all about and some numbers across. And I'll set that, the headlines of this entire discussion, and then the experts will deep dive into, right? So satellite constellation, which we talked, it's basically an artificial satellites, which is basically in coordination. It works and it gives a purposeful service, right? That's what it is all about. The primary purpose, what is the use of the constellation? You know that the Earth is, global and round, and then you want to have global or near global, any given point in time, at least one satellite is visible to us. Hence, we get the continuous service, right? And orbital is also concerned. I think let us also understand 3 orbits, basically LEO, MEO, and GEO, right? It's all easy when we use the abbreviations, but when you are new, I think it will be a difficult one to understand. So basically, the LEO is a low Earth orbit, which is basically 160 kilometers to close to 1,000 kilometers in the altitude. We call it as a LEO. And GEO is 35,600. That's what close to 36,000 kilometers is GEO. Anything between these two called is MEO, just to make the things very clear. So when we talk about the constellations, so where basically the market fields are going in. Closely, if you see that 50% of such constellation is predominantly, as rightly panelists were telling about, it's on the communications, right? And then 40% for Earth observations, and then 4% is for space observations. So that is the split currently. So that means the primary use case for this constellation is utilized for the communication predominantly, right? So basically, if you look at the trajectory basically on the orbital spacecraft way back in 2014, it's only few hundreds. I think now in 2026, I think it will go to tens of thousands, right? So that's the trajectory which is going. What does it mean to us is, I think the constellations are becoming the norm and then the requirement. I think then everybody wants to have that constellation, right? Even India, we have done that, IRNSS for various purpose, right? And when the space is concerned, then another important thing is, whether we like it or not, it's going to be the fourth war front, right? When we talk about all the 3, the future is going to be on that, right? So geopolitically, everybody is thinking that they need to have their own control. Otherwise, you also know that recent past what has happened in some of the incidences, right? So hence it clearly calls out to every nation to be at least self-sufficient or aware of where their satellites are and what services they are getting into. Let me also talk about how the constellations are happening, right? So constellations can be multiple satellite when I said, and then connect to each other and give the services. So that's also basically, if you see that how many such satellites are in orbit or in the plan, 48% of these constellations are less than 50 satellites, right? So there is a question, is the 50 satellites are good enough to cover the entire operations? The answer is yes and no, right? It's purely based on the use case. But today, the deployment is 48% less than 50 satellite constellation. 22% basically it is from 51 to 150, right? And then 8% of 150 to 500 satellites in the constellation. 6% only it's more than 500 satellites. It's only, what does it means to us is basically the big players, the few players which they are going to really, I could see that occupy the space in future, right? And then we will also talk about the nuances of those things. And 16% it's unknown, right? Basically, the publishers have not really put into the public mode, yeah. And we also talk about the satellites, right? The satellites, when you make the constellations, you cannot put the 6K satellites in the geo and make their constellation. It's going to be a very difficult, right? That's when our panelist was talking about, I think Elon Musk and team has really redefined the space science. And it's a questionable, it's the right way to do that without clean room, I make a satellite. And it's a debatable, right? So, but at the end of the day, they looked into the, time to market. I can do it so many satellites. I don't really too much worried about the quality for the longevity. When something fails, I can do it again. But it also creates a ripple effect of debris, which you are also creating in the space, right? So this is where the things are which is going in. So basically, I think less than 1 kg satellite, we call it as a pico. It's in 1%, 30% of nano satellites, 1 to 10 kgs, which does the specific purpose. 17% of the micro, 11 to 100 kgs. And predominantly, if you see that 3% is the large satellites, which is in the constellation. So now, when we talk about the constellation quickly, the technology is going to be the great, right? Because you have one satellite, the downlink, and managing, right? That's an erstwhile I was in ISRO, managing the one satellite and getting all the use cases done itself is not an easy. That's what it's called as a rocket science. But when you talk about the multiple satellites, the technology has to be, really rigid and, fulfilling all the required operations. So increasing number of satellites, basically, I think, as you know, that Starlink has got an approval to launch 42,000 satellites. So already, I think they are around 6,000 in the orbit, right? So the moment when it is there, similarly, SATCOM is concerned, I think Intelsat is around 52 satellites, Eutelsat 36, Inmarsat 14, all those things which is coming in, and you need to make sure that your technology is capable of communicating with each other and then working with the downlink and if required with the other satellites also, right? So AI automation, then it comes to the manufacturing. When I talk about the small one, right, you need to have the better manufacturing, adaptive, 3D printing, all those things, the technology plays the communication is going to be another one. I think pretty much, the radio frequencies are the thing now, I think the laser which is coming in. So the more and more the satellites when we go in, the technology has to make it. And a miniature of the satellites, basically we talked about, and then laser communications, right? These things are very important. And quickly I will talk about, what are the satellites, then operators, what is the purpose, predominantly just for your knowledge. Starlink is SpaceX company, predominantly provide the high-speed internet connectivity. Kuiper, I think from Amazon, I think to provide the global broadband access. And Pixel, I think hyperspectral imagery, I think they are also, their vision is really great that when they are launching their satellite constellation, I think that will add a lot of use cases to be real. And
sorry, who are they again? I didn't catch who they were.
Pixel Constellations. So there is a company called Pixel, which they are concentrating on the hyperspectral imagery. I think they will launch, perhaps I think some of the audience are here. So they will specialize only in the hyperspectral. They will launch 4 to 5 satellites in the...
So they're EO, not communications.
EO.
I mean, actually just wondering whether you could sort of wrap up in the next
quick,
2 or 3 minutes.
Yeah, I'll do that, yeah. So we also talked about, what are the business opportunities? Quickly, I'll take you through that. I think global internet coverage is the major one. Earth observation we talked about. Internet of Things, so this will enable a lot of IoT devices in place. Interoperability, enhanced communication services. Backup connectivity, something which is happening in the terrestrial network, right, due to some natural disaster. I think this can be a backup, and particularly for communications and then video conferencing and data collection also. The more the data. I'll take in a minute to talk about the challenges. When we talked about all the nice things about that, what are all the challenges, right? So when you do the constellation globally, the political is going to be the big one. So regulations and licensing requirement, policy uncertainty between this. If I'm an operator which I have to work across the globe and I need to satisfy all the policies, it's going to be the big challenge. Economic high initial investment. Basically, I think now the trends are coming in to reduce the overall cost, but still for any company to start, it's an high investment. And ROI, and is the institutions are ready to fund you for certain things are very uncertain in terms of the policies. That's the question, right? Social, basically when you seek out about debris, right, as we talked about, more and more satellites going up, after that service it is going as a debris, and how will we manage the debris management, right? And then debris can come to here, we need to have a self-autonomy, that debris is not coming and do that. And it's also EM radiation. The more and more you launch, and then more and more things are there, it's also increasing the electromagnetic. It will cause an Earth. Technically, basically, inter-satellite communications. And then when we talk about environment, we talked about space debris, ecological cycle. You know that very interestingly, some of the birds and animals which they migrate from one place to another place looking at the star. But today, there are so many satellites. I think that's also creating, confusing them even in terms of the migrations. It's a far use case, but that also will happen when you increase more and more. And then basically the legality, right? So liability. So for example, some debris has come and touched somebody's installation, and who will be responsible? Liability. Do we have really that framework? The answer is yes and no, right? It's a partially. I think that's need to be it. The final thing is the cyber threat. So even we talk about so much advantages, that there are a lot of challenges to overcome. It requires a global reform. Basically, I think we need to have the governance of these things. Who has to do that? Today, if you see, Starlink has almost occupied that particular spectrum, right? So I don't know what will happen. At first come, first service basis will sustain, or they need to have some strict policies to allow them. Who can do that? What purpose and all those things? These are all the questions that to be answered. Thank you so much.
Thank you. Before you get, interesting about the bird migration. I'll have to chase that one up. Just going to your point about the liability. I mean, what do you think is wrong with the current outer space treaty and the way in which that's working?
Perfect. See, today, if you, in my view, based on my understanding, the treaty is there, but now it's on the controllable way, right? Because now when you talk about 42,000, Starlink alone will go, and then rest of the companies, and the treaty has to be really amended accordingly, because now it's all about a smaller area, how many people can be in, right? So there are 100 people, which everything was set for this room. Now you are making it to 1,000 people, so we need to do. So that's what I'm talking about.
Thank you very much. So, Aj, I'm going to ask you a tendentious question. Your company builds geostationary satellites. Is the geostationary satellite market dead? Is it going to be taken over by the non-GSOs? We have a view on this, and the answer is it's not dead, and I'm sure that you might agree. Relating to, say, things like capacity density. Well, let me answer the question before you. If your board says to you, guys, and it's the same, for Sethu, the NGSOs are going to be taking over. What's the point of having geostationary satellites? So, what's your response?
In a word, no. And just to expand on that, actually, it's a great example to give in terms of the whole thesis of our entire existence, and that we justify to our board and obviously to our investors, is that we think of SATCOM and the consumption and availability of SATCOM geo data. It's really like economics 101. There's almost perfect price elasticity in that our entire thesis of our company is to innovate and focus R&D to constantly reduce and bring down the cost of satellite capacity, and then to pass on those savings to the market. And history shows us that the more capacity you provide, the more you reduce the price of it, the exponential demand, the demand is just exponential and goes up. So, I appreciate Alex's slide earlier that showed the different constellations. And right now, I noticed on the GEO, it's mostly the established or legacy GEO providers. In a very short time, I mean, we've made the public statement that by the end of the decade, we'll have 100 commercially operational geostationary satellites, and the end of the decade isn't that far away. I'd extend an invitation to everybody in the panel and everybody in the room the next time you're in California to come pay us a visit to our headquarters and factory. We've literally built a space factory in the heart of San Francisco, and it's really, we like to fondly refer to it as Disneyland for adults, because we've got all the toys and all the machinery in there. We do mostly our own R&D and sourcing of our own materials within that building. But what you would see if you came to visit is that we're building production capability to be able to ramp up and build 24 satellites a year. And so, and we're getting a lot of interest in the market, both commercially around the world, as I mentioned earlier on, and then, obviously we work closely with the US government, various departments, DoD, NASA, Space Force, etc., and for which we're seeing a lot of demand both there, and they obviously encourage us to work with friendly partner nations around the world. But just to sum up, we're going to keep reducing the cost. So right now, we pride ourselves on being low cost and quick time to market. And as we progress and evolve further, we're going to keep reducing that cost. And like I said, GEO's around for a very long time, and we're only focused on the SATCOM part, and so cellular backhaul, enterprise grade, secure, dedicated satellite capacity. And so, we see a lot of growth, a lot of demand.
So your thesis is that you're going to be addressing the market at a much lower cost per bit than the NGSOs?
Yes, we're doing it now, and we're not going to stand still. We're going to keep the majority of it. We've got about 350 people now. The majority of people are focused on R&D, and with a specific focus to keep reducing the cost. And so there's a space segment and there's a ground segment, and really we position ourselves as satellite capacity as a service. All right, and so CFOs and CEOs tend to love our model because with low to no commitment, we go build, test, certify, launch, insure, and only once that satellite is commercially operational does a given operator then pay a satellite lease capacity fee. So we've taken the whole risk model is very, very customer, as in like satellite operator on the ground friendly, and so again with that we're seeing a lot of demand.
So how do you compete against the guys who are building larger GEOs that are going to be typically less cost per bit?
So the best way I can answer that is, it's interesting. When I first came in, I joined Astranis 2 years ago, and it's the first time we set foot in Asia Pacific at that time. And now, like I said, we've made a number of sales and grown a really nice, healthy pipeline. Now, when I came in, I honestly expected the bulk of the conversation with customers in the market to be how we contrast with traditional GEO, which is, and actually what I found is, that's not even 10% of the conversation I typically have, because typically, customers and operators and market, the response is, yeah, we get it. We're quick, low cost, and, we're not designed for entire continents. We're typically designed for a given country. And so, in any given market, there's a segment that we can own and grow, and, alongside traditional GEO, because so price per bit on a traditional GEO typically assumes full occupancy, right? And so, and over the life of a 15, 20-year traditional GEO, it's questionable when, the utility, how often that is completely full. And just to expand on that, typically the question we get is really how we compare to LEO, and so that LEO's been good for business actually. What I'd like to say and think is LEO's grown the pie, and so before for the longest time, I feel like satellite has been an exclusive club, mostly for satellite guys. And whereas now, people that used to previously think data center and only fiber, they really look at a satellite like a switch in the sky. And so, it's really not an exclusive club anymore. And so we can demonstrate low cost per bit, both against GEO and LEO, and dedicated, secure bandwidth.
So I'm going to go to audience questions in a minute, but first of all, Sethu, how do you compete with Astranis? I mean, in terms of talk a little bit about ReOrbit, because I've just been told that you're on the panel, so it'd be a good idea to figure out where you're coming from.
Yeah, I mean, our primary focus is also small geo, and I largely echo what AJ actually said in terms of small geos. I think the key differentiator between us and Astranis is we don't lease capacity, we sell space infrastructure for nations. And primarily our focus has been on, let's say, the non-civilian part of the side. So today, if you largely look at the critical communications that the nations have been doing, and I think Damodaran rightly mentioned that space is becoming the fourth force, or probably even third force now. I guess some of the forces are sort of coming back. So a lot of these nations do have a large capacity requirement, and today the options they are left with, I can take Finland as an example. When Finland doesn't need 60 gigabits per second, 70 gigabits per second, or all those, right? Like if Finland wants to have its own sovereign capability, I mean, 10 gigabits, 15 gigabits is good enough. And then the capex comes into play, right? Like what AJ said. Because today, when you talk about cost per megabit, you're actually talking of the whole satellite being fully filled, and that's not the case. Like if you take any of these geo satellites, they're probably 60% full, 40% full. So then you have to take that into perspective. And also, if let's say Finland as a nation wants to own the satellite. I talk about Finland because we come from Finland. So if Finland wants to own a satellite as a nation, I mean, they just want 10 gigabits, and they can actually easily afford 10 gigabits, a dedicated satellite from a company like us, or Astranis and others. But I'll also go into an interesting point, because now we spoke about a lot of numbers, right? But then if you start dissecting those things, today you have the terrestrial networks and then the non-terrestrial networks, and it's a given that where you have a lot of crowd, like Delhi, like you will never have an NTN dominating Delhi because the cost is non-comparable. So where you actually have all these big constellations coming in is where you actually don't have access. Let's say the Lapland of Finland, which is far in the Arctic. It makes sense to have the the connectivity there. And that's why, I mean, the number that you actually rightly asked, where it's going from 107 to 122, is actually a reflection of this, that the SATCOM market, or let's say the broadband market, will be dominated by the terrestrial networks, and the NTNs would play a role only where there is no coverage. And then it has to saturate at some point, and that's the saturation you're seeing.
Right. By NTNs, you mean non-terrestrial?
Non-terrestrial, yeah.
Right. Can you just expand a little bit about what an NTN is for the audience?
Yeah, NTN is basically the SpaceX, what they're doing, all these guys. So these are basically satellites. Let's say they are flying base stations, if I have to put it very simply. So today you see all these cell phone towers. So these are the carriers of data today, right? Telecom data. So it's very easy or cost efficient to basically establish towers. I mean, I originally come from India, and you see a lot of houses where you have these towers on top of your house, right? So it's very easy to put those infrastructures. So it's very cost efficient. Whereas non-terrestrial networks are basically, you're taking, oversimplifying, but you're basically taking these towers and putting in space, which is what SpaceX and the likes are doing. So that's the NTNs. And again, as I said, the big role for NTNs, or the non-terrestrial networks, or these satellites, would not be on the broadband as it is, but potentially I would say the big role would be more on the defense side, MILSAT. That's where the big role would be, because you today cannot actually channel the critical communications or MILSAT data on an LEO channel, or on these similar big mega constellations, because if I have to sort of compare these mega constellations, these are like public transportation, right? And you, as a armed forces, don't want to carry your high secure data on a public transportation. You want to have a very secure channel to carry your high transportation data. So that's why, like, always your high critical data is always flowing through geos, and that market will stay. And that market will expand because literally 90% of the nations globally doesn't have its own infrastructure.
Right, but I could say to you, I have my own sovereign, or I'm looking for a sovereign satellite solution. If I've got a single satellite solution, that's easier to compromise than a multiple satellite solution. So why would I want to go with a GSO, maybe a geostationary orbit with 1 or 2 satellites, when I can go with a multiple 100,000 satellite network where it's much more difficult to compromise that?
So one, I mean, with the let's say geo, I mean, you could design it as a pure bend pipe, right? So your just data is flowing through, and with all these, let's say, highly software-defined stuff that are flying on the LEO, so then the cyber threat becomes quite relevant. And 2, also in terms of, I would actually say having a big constellation is much more unsafe, because once you get into a system, you're getting into the whole system.
So that's true for any system.
That's true for any system.
It's not
that's right. Yeah, exactly. So in that sense, it's actually much more safer for these nations to have one. And again, it purely boils down to the cost.
Don't see why that would be the case. If you've got a single point of failure, that's obviously a lot more easier to compromise than a multiple.
It's the probability of failure, right? It's not the single point of failure. It's the probability of hacking a thing. So it's purely, let's say, I mean, you need to score a goal. You have a bigger goal post. You actually can score it a lot more easier than having a smaller goal post. So I would say that way. But again, it purely boils down to the economics of it, right? Like a nation cannot afford to start flying these kind of constellations. Like I can take Finland or Sweden, or the Nordics. I mean, they cannot afford 100 million to put, or maybe more than that, to put into a constellation.
But everybody wants sovereignty until they see the price tag.
Yes, true. And that's where the small geos will play a big role. And you're already seeing, I think it was from the or Novaspace now, where there was a report recently that, was it like 25% of all the satellites that were signed last year, small geos? And I mean, here you're already seeing like us plus, Astranis. So we are currently building for a couple of term sheet already signed, and AJ has already said about $1 billion. So you're already seeing, contracts worth $1 billion, over $1 billion, just within this panel. And now this market will grow because there'll be more players coming in. And you're already seeing a lot of the geo, traditional players actually reducing their size as well. Like if you look at all these constellations, they're coming down in size. So I think I see there'll be 2 things happening. One, the LEOs will start becoming bigger, and you're seeing that Starlink generation 2 is much more bigger, and geos will start getting smaller. And I guess the sweet spot would be around 750, 800, which is where we are already working. So I think it's good times for ReOrbit and Astranis.
I mean, 18 months ago, I would have said, yeah, Astranis and ReOrbit. The guys who are in there already, Thales and Airbus, they've got the software-defined satellite. They've got it all sorted out. Not. I mean, it's a disaster for them at the moment. I mean, Airbus is almost going to be going under because of $1 billion of stuff that they didn't realize. And Taz is thinking about doing a merger with Airbus. Are you guys going to be the guys that survive because these guys are just too big and they've just basically messed it up completely? But again, a very tendentious question, and I wonder what your answer might be.
Certainly, the delays and challenges from traditional geostationary operators is obviously a huge opportunity for us because, where there's existing commitments and timelines can't be met, by our very nature, like Sethu said, is to be, quick time to market is the primary core competency of, value proposition, what we offer. And so certainly that's a big benefit. And like I mentioned earlier on, that we're highly vertically integrated, with our factory in San Francisco. I mean, one of the benefits of that is, we get to control quality, we get to control cost, and we get to control schedule. And so right now, if you go to the, something you mentioned earlier on about the clean rooms, and if you go to a traditional geo satellite manufacturer, they have state-of-the-art, amazing facilities. But the reality is, just like all electronics manufacturers of all descriptions in recent years, they're actually kind of glorified assembly plants, right? And the schedules are highly dependent upon the weakest link, whereas what we have is highly vertically integrated. And so with that, better timelines, and for sure there's an opportunity there, but not just because of their challenges, but because of also what we mentioned earlier on, a growing market. So there's a number of factors driving the demand.
But you've got the same supply chain problems as Airbus has, have you not?
Actually, no. Like I said earlier on, about 70% of the entire build component we produce in-house. Outside of that 70%, it comes from within the US. And there's reasons for that, for, like I said, supply chain and schedule, but also just in terms of some of the customers and government contracts that we support. So all of that actually, look, for example, I got asked a question a couple of weeks when we were in Singapore about, well, hey, haven't you guys had some delays in your launch? And the reality is our next launch we have is coming up in October. But guess what? Yes, there was a delay. The delay's from June or July. Whereas when you talk about some of the traditional satellite operators, the delays or the replacement time for a failed satellite is years, right? And so no, I don't see the same delay.
Sethu, you've got your view on supply chain. How's that affecting you? Is it affecting you? How do you get around it?
Yeah, we take a completely 360-degree opposite view of what Astranis does. So we actually...
But in that case, it's not opposite.
Or 180-degree maybe, yeah, let's say.
Sorry, there's always one, and it's usually me.
Yes, yeah, true. So what we do is we don't build any hardware in-house, completely zero hardware in-house. So we have now developed an architecture where we have developed a software core as a backbone to our architecture, and then we procure every system externally, and then we just integrate in-house. So
isn't that just asking for trouble?
Actually, no, because that's how we control. Because let's say if we are building everything in-house, we are not as good as Beyond Gravity, or we are not as good as MDA to build antennas, for instance, right? Because they have a tested and proven systems, and we are actually relying on their heritage and expertise and the quality to basically bring it in-house. So in that sense, we actually ensure a very heritage system or tested and tried system on the hardware level, and then we just integrate those in-house. So in that sense, our quality is actually already controlled, pre-controlled through our suppliers, and then we do actually get a really good, let's say, deals, because we buy at bulk. So in that sense, we don't have to actually have a huge capex upfront. So
it's interesting to see. Completely opposite views on that one. Let's go to audience questions if we have any. Yes, the gentleman, two gentlemen over here. We're going to wait for a microphone.
Okay, so thank you for allowing me to ask the question. Thanks to the organizing committee for allowing me to be here. I'm Raman Patnaik. I'm in grade 7, and let me come to the question. So we have talked a lot about satellites and constellations, and trying to make sure that geo satellites are not dead. So coming out of all that, by creating Mega-Constellations, we are sort of also doing some great work trying to improve the services, but at the same time we are also asking for trouble, because for example, this morning or yesterday evening, whatever, between these two timings, we had a few satellites crashing into each other. So a Russian constellation basically turned into pieces because of space debris, something that causes a problem. Now, if two different constellations or satellites crash into each other, that is one thing to fix. But another problem is just friendly fire between two satellites. So two similar constellations, two same satellites from one constellation crashing into each other, or basically coming into one confined orbit. So we are just, aren't we just at the same time improving services, but at the same time cluttering LEO orbits?
So we did some work, thank you very much, for about 20 years ago for a company related to, called Teledesic. It was 840 satellites, some of you remember it, all in polar orbit. And the calculation was that if there would be a conjunction, in other words, a crash between two satellites up near the poles, then the debris field would have destroyed through an avalanche effect every one of those 840 satellites within about 4 or 5 hours. So it's a very, very significant problem. Damu, I mean, I think this is an area where, you know, Deloitte probably have a global view on that, and then of course you can speak to your HR people about employing this young gentleman.
View is basically, I think it's a very good question. I think that's when we, one side we are telling that we make a lot of constellations. Geo-LEO, I think that's a different topic altogether. The geo is a geostationary. We need to understand, right? Basically, it gives you a view to one place always. That's the purpose is different. Answering to your question, basically what is the answer could be, things were going, right? Elon Musk has got 42,000 satellites already, he has got the permission and he is going in so speed. Certainly that he will make a ring fencing of what that spectrum, whatever it is. Answering to your question, that's when the technology, for example, autonomy of these satellites, right? Basically, whenever the debris comes near to some satellites, we need to have some systems and the propulsions to move away from that, because that's available in some of the satellites. You have an AOCS, which anything which is coming under us, you can through the ground or through the autonomy. So those things have to come in. Lot of technology advancements has to come. Of course, this is going to happen soon. And then today, if it is Starlink, right, the way in which they go fast, and then 200K satellites, perhaps they don't require clean room and whatever I understand. Basically, it is like, okay, I'll do that. If it fails, I'll put in another one. But it's also adding an issue in the orbit. So long way to go. It has got both the sides. Yeah.
I mean, to what extent, you must be dealing with these questions. There we go.
Yeah, so, okay. Of course, we're having a responsibility launching these constellations, and this responsibility is also in principle given to the companies who are doing so. Theoretically, it can happen. We have to see, will it happen by an accident or by a man-made disaster? Yeah, there had been launches of anti-satellite rockets. The lower the satellites are, the easier to get them, principle, yeah. But in principle, the engineering done for constellations is also done with an understanding of the complexity. Because if you cannot do that, you also don't get the money together to launch that constellations. There are insurance companies, and they are also making their assessment to have safe constellations, yeah. We are not doing that to create a lot of space rubbish. Yeah, that's not the idea. I don't say it cannot happen. Yeah, we all know that. But I think we are taking, or the industry takes a serious interest to make it safe. Yeah. Now I want to say that on the GEO satellites, especially on the mini GEOs, this is an answer, in principle, to also building. Even in the same orbital position, yeah, even in GEO you can fly several satellites in the same orbital position. Even there you have to be careful, yeah. This is already done, for example, by SAS since years, yeah, flying in a square of 70 kilometers in a GEO, several satellites, and yes, it's a task to fulfill. Right. I fully agree with you, yeah.
But at the same time, if we are locating satellites in a lower orbit, that means hopefully if something like this happens, it will burn up and re-enter quickly and not stay for a long time.
Right, I mean...
Okay, very good point, because that's exactly what is happening, yeah. That it is more and more mandatory to make sure that you can bring down your old satellites. Because especially if we are going in these LEOs, yeah, small LEOs, you don't have the lifetime of 10 to 15 years or even more. You would like to replace them maybe even after 3, 4, 5 years. Sounds crazy, but this is one of the ideas, having smaller satellites, because the evolution of technology is going so fast, you don't want to wait another 10 years until you replace it, yeah? There's a cycle. And that's, of course, also a challenge in LEO especially, because whatever you have there, you have to replace rather more faster than in GEO. But also in GEO, I think this is one of the potential advantages of having these mini GEOs, that you are having a replacement circle much easier. You can adopt it on a country-specific need and allow, in principle, the sovereignty also of countries. They are not having the billions. Yeah? If we talk about a real-time broadband constellation, we're talking about billions, nothing less. Yeah? If we talk about a mini GEO, this is a few hundred.
I think you want to move on to another question, but I think you maybe you could have asked a better question and say there's a whole bunch of other things we need to worry about. First of all, we need to build into the design of the satellites the ability to be deorbited. But then there's the issues of radio astronomy and visibility of the nights. Not a problem. If two of them bump into each other, then the debris field is not going to be that great. But down at lower Earth orbit, it's a big issue, and it's luckily getting a lot of attention. Let me just see if there's any, because we're sort of almost.
It's a very important thing. Thanks that you are addressing it. I think you had a question.
Thank you. Yes, one more question.
Thank you very much.
Gentleman here, because we've got 5 minutes to go.
Okay, it's just a quick question. Thank you all. And it's a very good session. So I have a question, like all the industries are working towards generative AI technology. And as you know, in the space also, this technology is also entering. And I would like to know, in Mega-Constellations especially, how could be a potential application, or the satellite manufacturers use this technology?
Yeah,
Thank you.
If you remember when I started, I actually mentioned about the ability to connect and move data, right? So today, one of the core things that the space industry will move into is the ability to distributed computing in space, right? At the end of the day, what the end users want is real-time data from satellites. That's the crux of it. And today, the data sources are point to point. You have one satellite sending data down and up. But once you start connecting, which we are doing already, we have a proof of concept to demonstrate 100 gigabits per second on an ESA program that will be launched in 3 years. We're working on that, and also there are different other initiatives. And Starlink has already, I think they have the ability to do the optical intersat links. So once you have the ability to connect, then you would definitely start going into data stretching. You will be going into models where you will start processing the data on board the satellite and doing all sort of different things. So that's a trend that will come, and add to that the autonomy. So we actually, in fact, demonstrating the fully autonomous platform that will be launched next year for ESA. So it's a step towards actually going towards that. So once you have the autonomous systems, that's also like using the generative AI data, just trying to learn about itself, right? So those are the trends that are already happening at various levels, and I think it will go on to grow.
I just want to move on to one last question. The gentleman over here, yes.
Yeah, my name is Pallav Bagla. I'm a science journalist. As a user, why will I go to Starlink or to any other OneWeb when I'm getting 300 or 500 Mbps up to 1 Gbps on a fiber optic at my home? And all of India is going to get that very soon. What a waste of effort to have these constellations up there. Elon Musk can do what he feels like, but the user case in countries which are large density like India it's not going to be feasible. Even though Mr. Musk is likely to get his license very soon.
Yeah, there's a million people in the USA who've got great internet access, and they've all signed up for Starlink. But anyway,
I can take. Yes. I think I mentioned this, Mr. Pallav. I think the non-terrestrial networks will only be impactful where there is no dense population. I think that's where, and that numbers clearly shows where the market increase has been very minimal.
I would actually disagree with that, Sethu, because when these satellite broadband projects started, say, 20 years ago, it was HughesNet or Viasat, they reckoned that they would get most of their customers in the rural areas, and that wasn't the case. They found that most of their customers were in the exurbs, say 50 miles, 50 kilometers outside Dallas. And if you look at the capacity density requirements, demand, it was in the exurbs, in just outside the suburbs.
But you know,
I'm not sure whether you're nodding or disagreeing on that.
The problem is this. Actually, as Bagla said, right? I think these systems are designed for Western countries, but when it comes to countries like India, price matters a lot. And I don't think we like countries like African countries, the Asian countries, they cannot afford these, and that's where the masses are.
Yeah, if you look at Africa, for example, I mean, it's 3 times the size of the USA, 3 times the population of the USA, and if only 1% of the people can afford it, then that's a significant market. Let's just take one more question if we can. Rajiv.
Hi, I am Rajiv. I'm just trying to address what Pallav just mentioned. We have a Bharat Broadband Network Limited, but when I go to their annual report, I see that the uptime for that fiber network is 58%. I feel ashamed on that number. So while we say we have fiber going up to all the villages, please look at that number. Is that the kind of connectivity that we are looking at? And when I say 58%, that's an average, which means there are some sites which are 90% and some sites which are just 15%. These are not suitable for fiber network. These are the sites which will be served by satellite communication networks. Thank you.
No, but the devil in the detail is there, perhaps. 58%, and how is that distributed? And
can I just add one small comment?
Just
Pallavji, a TRAI indicator report, if you can check the latest report, 42% of India, rural India, is connected. There is a 58% of rural India which is unconnected, and fiber cannot reach there. And you can check the historical last 5-year reports as to how that rural population is getting connected. It's growing at 2%.
But the smartphone penetration says something else, sir. Please, but I think you guys are infatuated with satellites. You need to get real. There is this infatuation needs to go.
Yeah, we are at a satellite conference, so that may be a sort of a clue. Anyway, we have a few seconds to go, and so all I want to do is to say thank you to SIA, thank you to the audience for the very interesting questions. Thanks to our panelists, and we look forward to seeing you same time next year, perhaps. Gentlemen, ladies, and everybody else, thank you so much.
Thank you so much, Mr. Jeremy, and a heartfelt thanks to all our panelists for providing such valuable insights during this discussion. So at this point, we would like to appreciate the valuable participation and contributions of our esteemed panel members. I request Mr. Jeremy to please come forward and felicitate all our panelists. To please come forward and felicitate all our panel members. I request Mr. Damodaran Raman, Director at Deloitte Consulting, to please come forward for the same. Mr. Ajmair Heer, General Manager, Astranis Space Technologies. Mr. Alexander Jeuck, Senior Advisor, Novaspace. And Mr. Sethu Saveda, Suvanam, Founder and CEO at ReOrbit. Well, now I would like to invite Mr. Rajiv Gambhir, DY Director General, SIA-INDIA, to felicitate Mr. Jeremy Rose, Partner, Comsys LLP. Thank you so much. Well, I request all of you to please come forward for a group photograph.